Okay, guys, thank you so much for joining. Today I want to do Leetcode number 1, twosome. If you like this video, please remember to like and subscribe. It would really help the channel. So let's first go through the exercise. Given an array of integers, nums, and an integer target, return the two indices of the numbers such that they add up to target. So given an array of integer nums, for example this, and a target, find the indices of the two numbers, such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So here we have the example 1. Input is nums, is 2, 7, 11, 15. Target is 9, so we look for the numbers that add up to 9. The output here is 0 and 1 because nums 0 plus nums 1 equals to 9. So we return 0 and 1. So in this case, the target is equal to 9. So we add 2 and 7, and that gives us exactly 9. So the first thing you always want to do in these kind of exercises is to find the brute force solution. For the brute force solution, we are only going to talk through it conceptually, and then we're going to go straight to the elegant solution. So what would the brute force solution look like? The brute force solution would take the first element, 2, and then just iterate over every element in the array. So then it would start at index 0 for the first one, and then it would go to 7, and look whether this pair is equal to the target. In this case, we see that 2 plus 7 is indeed 9. So we return 0, 1. Of course, now it makes it on the first hit, but that doesn't always have to be the case. But because we, on average or in the worst case, we always need to check n squared cases, the complexity is O of n squared. Yeah, that's basically the brute force solution. And let me just remove this. And now we go to the elegant solution. So the elegant solution is quite interesting in the sense that for many exercises, you need to think, okay, how can I iterate through the array only once? That's often a trick that's very often used. And in this case, to solve this exercise, we're going to use a hash map. So what we are going to do is, instead of looking for target, which means we have to look at every array, we're going to look at the difference between the target and the number. So if we write, for example, that A plus B should equal to C, so we say number 1 plus number 2 is number 3, we can also look at A equals C minus B. So that means instead of looking at if 2 plus 7 is 9, we're going to look at, can we make a vector that we say C minus B, which is C minus B, so that's 7 here, it's 2 here, here we have minus 2, and here we have minus 6. So whether actually the number is equal to the difference that we need to make. So if we then start at this number, we see that the difference we need to make is exactly the same here. So the idea is to build up first this vector, and then for every element in this array, we're going to check if we can find it in this array. So say, okay, we take the hashmap 2, the value 2 that has index 0. So in this case, we have the value of 7, which is index 1. We have the value of 11, which is index 2. We have the value of 15, which is index 3. And then for the complement, so we call this the complement, we are going to look at, okay, I start at this array. Can I find this value in the complement? So then we do like, can I find this value in the complement? In this case, we do. We find the number 2. And the only thing then that we have to check is that, of course, it cannot be the same value. So we need to make sure that the index here, that this index is not exactly the same as this index. Because if it were, it would be the same value, and then we couldn't use it. So yeah, so what we do is we build up a hash map, and then we iterate over every value. And we look for the complement, and we look at if the complement, this one, is in the hash map, and it doesn't have the same index, so the value, so this one does not have the same index as we are currently at the loop. So in this case, it's satisfied because this is index 0, it's index 1. Then we just return the indices. All right. So let's go to the Leetcode. So first, what we need to do is we need to make a hash map. So we create a hash map, which is a dictionary in this case. You could choose a default dictionary, but it doesn't really matter. Then we need to build up this this hash map of values. So first, we're going to build up hash map. So we say for I in range len nums. So we iterate over all the values. Then we say hash map, and as the value, sorry, as the key, we take the value, and as the index, and as the value, we take the index. So we kind of swap it around. So we say hash map for the value. So that's the value. Nums I. We take the index as the value. Now let's run it so we kind of get a feel for what it looks like. This is wrong, but at least we have it matches, right? So 2 has a value of 0, 7 has a value of 1, 11 has a value of 2, 15 has a value of 3. And now what we need to do is we need to iterate over this array. So we go for I in range len num. So we're going to iterate over the nums again. But instead of looking for this and another one, so instead of looking for 2 plus 7 is 9, we're going to look, okay, can we find this value, this 7, this complement, which would add up together to 9 in the hash map? And if it is in the hash map, it cannot be the same index, because if this were index 0, then it would be the same number, and we can't have that. So we say, okay, let's look for the complement, which is the target minus the value, so minus nums I. And then we say, okay, if the complement is indeed in there, so if it exists as a key, so if complement in hash map, and the complement can of course not be, so the value of the hash map at the complement cannot be the same value as we are having right now. So we say, and if the hash map of the complement, so the index that we store, cannot be the same as the index we look at right now. If that is the case, then we simply return the index, which is the number we are iterating over, so that would be 0. And we return, in this case, that would be the value at the hash map. So we say hash map at the complement. And then let's run this. Let's accept it. Let's submit it. And then it runs indeed. So that is the solution. That's the elegant solution. And now what I want to talk about is, okay, what we always do is we solve these exercises. In this case, a hash map was needed to solve this. But now the question is, how do we remember this so that during an interview or during another problem that you're solving, you can actually remember this? And what I do, this is a personal thing, I use flashcards for this. I really like these flashcards. This is a free app called Anki. And what I just do, I usually copy over the exercise. So I make like a screenshot. I do like this, and then I say, okay, what a brute force solution of this, right? So what is the brute force solution? Usually a brute force solution is just where you iterate over all the possible values. So iterate over all possible values. And then we do that. But then we also have an elegant solution. I call it elegant. So I say elegant solution, and then we do like this. And what's the elegant solution? So the elegant solution is the one that we coded in, that we described. And that is to first create a value, first to create a hash map with each key as the value and the index, as the value as the key and the index as the value. And then to loop over the original array to see if you can find a complement. So how I would write this down is hashmap.complement to find complement. And what we then can do is we can test ourselves whether we actually can remember this. So I will study now. I say, okay, what's the brute force solution? And then usually the brute force solution is just to try all the possible values. So I say iterate over all possible values and then return if it's true. Very good. And then the elegant solution is to create a hash map where the keys are the values and the values are the indices. And then instead of looking for the number for the two targets, you look for the complement. So you say target is like complement is target minus nums, or just complement. And then the algorithm works in such a way that it spaces the repetitions in the beginning. They're really close, like really close. Like now I have to do it again, but we know this, right? So brute force is iterate over all values. And then the elegant solution is just to make a hash map and look at the complement. Okay, thank you so much. I hope you learned something. And yeah, please like and subscribe to help the channel. Thanks.